Video we are going to learn about global positioning system. Uh, in the previous classes, in the previous videos, we have learned about the analytical methods where you could find out the linear distance and angular measurements. So, if you want to find out the relativity um, of the a survey point uh, and its duration of stay with respect to time or with respect to the space parameters, so we normally go for global positioning system. So these basically it works. So global positioning works on the basis of series of satellites and receivers. So each satellite sends a signal indicating its position relative to the receiver, which means, for example, receivers are normally in the car or normal handheld GPS. So we do have satellites rotating in the orbit around the globe Earth. So these constantly uh, sends the signals, and these signals are captured, analyzed, and processed in the GPS receiver. So the signals, how it's been encoded, then receiver how it decodes the signals, then the time duration or time lapsing between the signals is calculated, and whatever the signal seconds the lapsing is there, that signals lapse is multiplied with the speed of light. So with the speed of light, if you multiply with the time, then you'll get the distance. So distance of a receiver with respect to satellites are calculated. So at least we have to have, based upon the principle of surveying second, at least in order to have two measurement two enough to in order to mark any point, you need to have at least two measurements. So minimum of two satellites are very much needed. So and if you have more than two, for example 5 or 6 or 7, something like that, you have a redundancy where you can get the more accurate values. So what how these satellites orbits around the globe is very important now. So you can see the globe here, where a blue color portion is where we are standing now. So we have totally six orbitals. In six orbitals, we have four satellites rotating around the globe. So these are aligned in a such a way that at any period of time, at any location, so you at least have the minimum six number of satellites. So as it is rotating, you can see the number of visible satellites count. So at certain location you will get 10, at a certain location you will get 6, at a certain location you will get 12. So I say, as I'm repeating this again, at any period of time, the minimum number of visible satellites should be 3. So if you have more than 3, then you have a redundancy. So just before we had an animation where it is showing the 24 GPS satellites with 4 satellites in each 6 orbitals. So the number of visible satellites, you can see. So as I said, the redundancy will increase the accuracy of your location. So with speed, with the time variant. So the mathematics or the theory behind the GPS location is, one satellite sends signals of its location, where it's where it is now. The another satellite sends its own signals, then likewise every satellite sends its own signals. And when you have a receiver getting these signals, say for example we have two signals from two satellites, so it means it is in the location of the intersection of those signals. So if you draw a globe or a sphere around a satellite, and if you also draw a globe or a sphere around other satellites, and your receiver must be in between those intersections, obviously. So it is still inaccurate because at any location your receiver can be at any this point, at any of these points. So if you have a third satellite when you are getting a signal, now the accuracy still decrease. See, there you have this much, now it decreased to a circle kind of a thing, at a given radius your point is located. Now if you have 3 points, say for example, if you another sphere is there, another signal, you have another two signal and another sphere, so these all signals come together and give you a certain radial or a certain accuracy where you can pinpoint, where you can locate your receiver. So that's our solution. So the normal our satellites have an accuracy of 12 meters radius. Uh, so this is the mathematics. This we call as a triangulation, right? So likewise, always said, I just want to read it out. Each satellite of the network sends a signal, indicates its position and the time of the transmission of the signal. So satellite itself sends signals. So it constantly transmits some signals. So that signal consists of its position and it's the time of the transmission of the signal, right? So since the signal travels at the speed of light, the receiver can determine the radial distance of the satellite from the receiver. That's what the diagram says, right? So next, the many think that receivers transmit information to the cell. No, it's not a reality at all. The receiver, the receiver, whatever it is there, it calculates each satellites. The receiver calculates each, uh, or the receiver collects the data of all satellites' position and the time of the transmission. After collecting the information of the satellite's position at the time of the transmission, the receiver calculates its own position based of their these things. So that is what the that it was the basic math. I repeat them again. The satellite's positions and the time of the transmission is collected by the receiver, and the receiver will calculate the mathematics to calculate its position, not not satellite position. Satellite has already been telling its position. So you can sometimes expect some errors in when you are using a GPS. So when you are using a GPS, it is always has a problem at the ionosphere and troposphere because we have many factors in it, and one of the main factors in this process itself is the time mechanism. When a signal is transmitted from the satellite, the time variance is the distance from the travel of the satellites itself is the biggest factor. So the satellites are always equipped with atomic clocks so that they will never have this timing problem, right? So that, and also the atomic clocks have a certain specialty where the timing is always accurate with milliseconds. So it is a millisecond variation. And also the receivers also have should have the accurate class, like we cannot carry an atomic clock, but it should have an accurate clock, so that if it does not have, then again you can expect some kind of an error in that. It's not required for you. And the other signal, other sources of errors you can expect is when you have a noisy channel, or when you are traveling in a tunnel, when you wanted to have the exact location, it's very difficult to have because you are not located in a signal zone of the satellite. And if you have its magnetic field and a gravitational field, these are also relativity of these forces will affect in the transmission of the signals or the receiving, or receiver receiving the signals of this. And these signal delays can be of atmospheric disturbance at sometimes also. So atmospheric disturbance in the sense you may be having a huge cyclonic effects and all those things. So these are the main things which I want to discuss with you. Thank you. In the next class, we'll discuss about uh, the uh, what are the electromagnetic waves, and how this GPS signals works. Thank you.